right? It is solid. So the option will be what? D, none of the above, because lard, if it's high on saturated fatty acids, then it should be solid because of the single bonds. So the correct option will be D. Now, we're gonna go over isomers, right? As I promised you, we have to cover positional and chain isomers, which are the easiest ones that you can ever think of. So, this is the definition of a positional isomer. So, you have the same carbon skeleton and the same functional groups, but they differ from each other in the location, thus that's why it's positional, of the functional groups on or in the carbon chain. So in this example right here, you have this bromine that is on this carbon number 1, and then you have this bromine which is in carbon number 2. So they both have the same molecular formula. It's just the position of the functional group that is different. Please, please, please do not confuse them by functional isomers. For functional isomers, you do have complete different functional groups. But for positional, it's the same functional group, but it's just moving to a different location within the carbon chain. Okay? You need to rewind this. Okay? Please make sure you understand. For positional, you have the same functional group. You're just changing the position of that functional group. You can have also, if you look at ketones, right? The carbon oxygen double bond, if you move that around between the same carbon chain, that will make it a positional isomer. For positional isomer, you're not changing the functional groups. But for functional isomers, you are changing the functional groups. But for positional isomers, you're just moving the position of the functional group, okay? So that's really easy, okay? Now, for a chain, this is the definition of a chain isomer. So you have the same molecular formula, but different atomic arrangements or branches. So you're only looking at the carbon chain, okay? Nothing else. You're just looking at the carbon chain. If you look at this example right here, you have hexane, and then you have 2-methylpentane and 3-methylpentane. Okay, I know that you might argue, well, you are changing the position of the methyl, but no, it's not a functional group. It's just the chain of the carbon backbone, okay? We're only looking at the differences of the arrangement of carbons for the chain isomers. I hope that's clear, okay? You're just looking at the differences between the carbon chain and whether if you have more branches or not. You're not looking at the position of the functional groups. This will be positional. You're looking at the atomic arrangement or branches of carbon for a chain isomer. Okay, I got really excited about talking about positional and chain reactions, but let's move on. Okay, so now we're going to cover a little bit about sequence of reactions. So on your exam, you should be able to name the molecule in UPAC. If you're given the name of it, you need to know whether if it's a carboxylic acid, an ester, alkane, an alkene. You need to identify that. But in this case, I'm giving you the structure of the molecule. So for this reaction, you're starting with an alkane, okay? And then you want to go to an alkene, and then you want to go to a secondary alcohol. Okay, now I added here for our purposes the table that you will have on your final exam. So how do you go from an alkane to an alkene? So from this table, what reactions or what starting material is the alkene? So I'm looking at the only one that has an alkene as a starting material will be the first one, which is a halogenation of alkenes, right? And you apply heat or light, and then this halogen, and then you get what? An alkyl halide. So now, are we done? Are we at the alkene yet? No. So how do we go from the alkyl halide to an alkene? So let's look at what reaction starts with an alkene. So I'm looking over here, you have the X, you have an alkene here, and I guess that's it. So this is the only option that you have. What reaction is this? This will be a dehydrohalogenation reaction. So you react your alkyl halide with KOH, potassium hydroxide, and alcohol, and then ta-da, you have your alkene. So again, what were the steps to go from an alkane to an alkene? You first had to do a halogenation of alkanes with heat and light and the halogen. You get your alkyl halide, and then you take your alkyl halide, and then you go through dehydrohalogenation with potassium hydroxide and alcohol, and then you get your alkene. Now, we need to go from an alkene to a what? An alcohol. In this case, it's a secondary alcohol. So, just so you know, whenever you have an alkene, you want to get the most stable one. So the most stable in this case will be the what? The secondary alcohol. But if you had, I'm answering one of the questions here. So if you had, imagine that you had a methyl group right here, then you will get a what? A tertiary alcohol, because you will have 3 carbons surrounding the carbon that's attached to the OH group. But let's go back to this. How do we go from an alkene to an alcohol? Let's look at our table right here. Which reaction starts with an alkene? So I'm looking at this one right here. You start with an alkene, but what is the final product? It's an alkyl halide, and we don't want an alkyl halide. We want our alcohol. So I'm looking here. This is another reaction that starts with an alkene, but what is our final product? It's back to an alkane, and we don't want that. We want our alcohol. So another reaction right here that I'm looking at, that you start with an alkene, you react it with an acid and water, and ta-da, you do get a secondary alcohol. You do get an alcohol. So this is the reaction that we want. And if you remember, this is my favorite reaction, which is a hydration reaction. So you do a hydration reaction with acid and water, could be sulfuric acid and water, and you get your secondary alcohol. Yay! Okay. And of course, hydration reactions, you're adding a water molecule, right? So therefore, it's an addition reaction. Now let's look at these questions right here. If starting material was an alkane, so if the starting material was an alkane, how can we get to an alkene? And we did cover that, right? So what were the steps again? You can rewind this video because I don't want this to be too long, but you did just very quickly. You did a halogenation of alkane, you got your alkyl halide, and then you use your alkyl halide and you did a dehydrohalogenation reaction to get your alkene. Question number 2, can we only get secondary alcohols in the hydration of alkenes? Well, you can get secondary, but not only. If you had a methyl right here, in this case, the OH would be added here. Imagine you had a methyl, okay, here. So that will make it a tertiary alcohol, but in this case, it was a secondary alcohol. And again, when you go from an alkene to alcohol, you're adding a water molecule, and thus that will make it an addition reaction. Okay,